Hey there, you've wandered onto the VUC, a weekly conference produced by IP Communications and VoIP Community. We would like to thank Simwood.com. Simwood can turn you as a developer into a telco. Our hosted PBX is from OnSIP.com. You can get a URL that people can click to call you at onsip.com/getonsip. Speaking of SIP, we use the best PSTN and SIP conference bridge in the world, zipdx.com. Our website at vuc.me is on bluehost.com. And thanks to Voxbone for our world local rate dial-ins. Alrighty, thank you, Michael, for the pre-roll, and we're April 14th, 2017. We're going to be talking about the future of SIMs in just a second, but I want to talk to you about the future of May 8th and Kamailio World, where many of us are going to be there, and that is May 8th through 10th. It's in Berlin, Germany. Go to kamailioworld.com to check that out. It's, in my opinion, the best thing that happens in Europe of its type. I'm going to turn this over to Mr. Tim Panton, Steely Glint. And Tim, take it away and let's introduce our esteemed guest.
Right. Where are we? Yes, cool. I have audio. Fantastic. Yeah, no, Rudolf van den Berg is somebody who I've discussed stuff with on Twitter over the last couple of years, and we were having a discussion maybe a week or so ago, and it was one of those things where I just felt 140 characters is really not enough to get this topic sorted out. So, and I think it's seemed like a good opportunity to try and have a proper long form discussion about. So, so that was how this kind of started. And really, I guess we should do our traditional thing. We always ask guests this, just kind of, I think mostly to slightly annoy them and embarrass them. But we ask them how you got into the technology that you're doing now. Like, did your dad give you a radio when you were 5, or how did you get started into technology? What was the first thing that got you into it?
Oh God. In my case, I went to Twente University to study public administration and public policy, which was the least technical course there except for applied education technology. And otherwise, Twente University in the Netherlands is a very technical university with interesting courses like applied physics, applied mathematics, civil engineering, electrical engineering, those kinds of things. And then I was doing a course that had just one course of math in it and nothing else. But I quickly found out that I had a knack for technology and for networking, and I quickly found out that I had all the wrong friends, basically. So my friends were running the campus network to the university. Now, this was quite a funny network, because in 1994, the university decided that it needed something different, and it wanted an Ethernet network to all student rooms on campus, all 2,000. Every student in 1994 got 10 megabits. So that was pretty decent. By the time I was asked to join the board, we had 100 megabits switched to each student room. That was around 1999. And it was by far the fastest campus network in the world until Case Western Reserve University decided to give everybody 155 megabits of ATM to their student room, except of course that their network cards costed $1,500, and now it's costed roughly 20-30 euro at that time, which was a pretty good deal. And I was asked to join the campus network board because I had a knack for technology and I understood policy where everybody else was basically a nerd. And I was a nerd, but more on the policy side. That's how I got into the business. And then friends of mine started their own data center, and it came with an internet exchange point. And since the internet exchange point was a combination of the university and several local governments and investment funds, And they needed a policy guy to help them out. And so that turned out to be me. And 2001, I started my career there working at the Dutch-German Internet Exchange Point, just when the whole world was collapsing around us, all of the telecommunications industry. So that's where I got my career start. And after that, I went 5 years to the Ministry of Economic Affairs, doing lawful intercept policy, and later on all kinds of telecom strategy. And then after that, I joined Logica in the Netherlands, which was then a management consulting firm, quite well known in the UK as well. I got a question from a customer, Dutch Rail. How do we move our 10,000 SIM cards that are in trains now from one mobile operator to another? And that was a very interesting question, but a very difficult one. And it turned out that it could have been very simple if they had their own numbers. But getting numbers was illegal because they weren't a public provider of telecommunication services. We actually applied for numbers. So that became a whole discussion with the ministry, who then asked us to write a report on it, on what possible solutions could be. And basically we said, well, government should allow private virtual network operators to exist. So large-scale M2M users who manage large numbers of SIM cards should be given the right to have their own IMSI numbers, to have their own phone numbers, and all that stuff. I then left for the OECD in Paris, where we advised 34 countries on telecommunications policy, and they liked that topic a lot there because it's basically the last area of market competition where telecommunications really needs to get more competition, because in many ways it's very weird that you can now have a car company with multiple million devices and they actually literally have less choice once they've picked a provider than the average consumer has, because they can't switch mobile operators anymore once you're stuck. And all of that has to do with the SIM card and the numbers that are on the SIM card, the IMSI number. And all of it is attached to one provider. You all may have heard of eSIM. When I started writing on this, the GSMA had just published a report on eSIMs, stating that it would never, ever, ever allow eSIMs to exist in the market. Then when we were writing, all of a sudden Apple came around and said, look, we're going to try eSIM, and that caused a lot of uproar in the market. And then our report came, and I presented that also to the GSMA, the relevant working group. And after that, all of a sudden, there was this 3GPP working group on eSIMs, and took them a long, long while of press releases saying that it would be done in 6 months to finally get something going, which they did last year. Basically, it's more of a GSMA standard than a 3GPP standard, because there are still parties very much against this kind of development. But that kind of got me going. These days, I work for Stratix, which is a telecom consultancy in the Netherlands. Work on this previously. Just recently, we wrote a report on how the Dutch blue light sector could get their own spectrum and run a private virtual network on top of other operators in the Netherlands. So we will see what the government does. They likely will get 8 megahertz of spectrum for their own private LTE and then buy commercially for a whole bunch of others. But that was basically our advice, that that would be the best solution for them. So that's very much in line with what's happening now. And that's kind of the introduction of who I am and where I come from and what got us talking about this.
Wow, I've got so many notes now from that. There's just like a whole bunch of stuff, but it's cool. So particularly the thing that sparked me in this discussion was I saw an advert this week for a device which I actually don't have yet because it has to come from China, but it's the Orange IoT Pi. So it's a little Chinese device, and in effect, it's looks pretty much like that. $11, and it's got a full, actually 2G device and a full Raspberry Pi on the same board. And you look at that and you think, actually, it's going to cost me as much to put a SIM in it and provision it as the board costs. And,
yes.
and when you look at that, you think, how is that possibly going to scale to hundreds of thousands of devices? Like, you know, there's no way that the people who make my oven or my, you know, the thing that opens my garage door, that they want to be trying to do a deal with phone companies. Like, you know, it's just too unpleasant, and certainly not provisioning SIMs. So I'm very skeptical that the SIM is the right solution. But on the other hand, if you want the kind of coverage, the way that the spectrum's been divvied up, you're kind of obliged to go with whatever the phone companies want you to be doing. So I'm torn between thinking that the SIM is doomed, and it's got no role in IoT whatsoever. And then on days when I look at who's got the spectrum, I think actually it'll be whatever the spectrum holders want it to be. And if that means that your device costs another $20 to ship, then tough, you'll have to go for it. I mean, the other thing about it, and the eSIM is a really important part of that, is that there's a huge mechanical problem with that, because I've got a set of contacts that, if this is in a vibrating device, that can rust and fall out, whereas you just don't want to be in that position. Everything else is soldered on, but the identity module is detachable. I mean, you know, how can that possibly be a good idea? So yeah, I think there's a bunch of kind of really difficult stuff there.
Well, first let's got away with some of the stuff that's just not correct and less interesting. For example, the mechanical vibration stuff. You can buy industrial grade SIMs now that you can solder on and put a dollop of glue on it and make sure that it never moves again. So that kind of stuff is readily available from major suppliers, probably in quantities of 10,000 a pop. But still, it is very well possible to build a board with a fully qualified, and that's what the big car companies are doing at the moment already. They're not putting in SIM cards. Because in the end, what is a SIM? A SIM is nothing more than a chip that, in this case, comes in a bit of flexible packaging. But of course, you can just solder it on if you want to. Just in the past that we never wanted to, now we do. But the SIM, its most important part is that it provides very good authentication. And therefore, it allows you to build. And billing is, of course, what you need for certain applications. Not for the stuff that you won't have in and around your home, but for the stuff that roams around. That's where you want some pretty decent billing infrastructure to work. Because if everything can just send up data, there's no way to run a business. So authentication is very important, and particularly in high volume situations where you have a multi-network roaming situation, so where you don't have one network that you can use. It's roughly the only way of making it work. And anybody who has tried Wi-Fi across the globe knows how hard it can be in certain places in the world to hook up to Wi-Fi with all the splash screens and the stuff that you need to work through. If you have a container or a car or anything, and it would actually have to negotiate all the various different bits and bobs that you have to go through to get hooked up to Wi-Fi. Yes, Wi-Fi is everywhere, but not for IoT. It might as well not be there. For IoT purposes, it just doesn't scale. And SIMs provide a very good way of authentication, so much so that you can pop a SIM in any car, drive it around 100 different countries, and it can hook up to any of the mobile networks there, given your provider is somebody big enough to have roaming in those countries. But other than that, it just works. And from a business perspective, that's a lot more interesting than everything else.
Yeah, I think that the place that makes sense if you're talking about trains and cars, because the additional cost of provisioning a SIM is compared with the cost of provisioning a train is probably not very significant. But when you start looking at smaller devices, and where the supposed 2 billion IoT devices, or whatever the number is from at the moment, those devices, that the economics of provisioning those through a mobile network and typing in the IMSI or whatever, however the process works, doesn't.
That's fully automatic. That's the moment.
So it isn't. It's fully automatic for the vendor of the device, but for me as the owner of the device, if I want that to be part associated with me rather than so if I want to here's the philosophical thing, which is that if that device is mine rather than owned by and rented from John Deere, then it's a different relationship. And the SIM perpetuates the ownership by the manufacturer.
Yes, but then again, if you want to own it yourself, and it's from there, you have to hack it yourself. In some ways, look, a lot of stuff that's sold on the market just needs scale, and you don't want to be looking at 20 different subscriptions for it. If you're on it, you want to own it, but you probably need a service provider to go with it. Certainly if you talk about a couple of thousand devices. If you're smaller than a couple of thousand devices, well, it becomes a bit difficult to see why a business case wouldn't fly because then it starts to become easy enough to do it by hand yourself. You could hire a couple of students and the SIM in. But other than that, if you run a couple of thousand devices, you're talking about scale, you talk about automatic provisioning, you talk about provisioning from the factory, and then you want strong authentication in a way that you have good control over. And
so my argument with that is that you're authenticating the wrong thing. What you're authenticating at that point is the manufacturer, not the end user.
Well, even there, if you pop in an eSIM, so that you can actually move from one provider to another, that would be.
That's what happens with the iPads, I think.
No, not really.
Okay.
iPads are a bad example in this case. It really depends on the provider that you're with, and still, basically, Apple doesn't have its own credentials, so they load the credentials of the operators on it. But if you look at what we advise in the Netherlands to the blue light sector, basically what we advise them to do is to pop in their own SIM, become their own provider with their own mobile core, and then scale it from there. And then you can work on multiple networks at the same time. You have the full authentication and the billing. You have the reliability that the authentication is really your devices and your data. But the Netherlands at this moment is one of the few countries in the world that allows you to become your own private virtual network operator. We now have one major smart metering company, one of the major network providers that has done that over KPN. The EU is currently looking at regulation of allowing it EU-wide. But at this moment, you are more or less stuck, because at this moment in the EU, or anywhere else in the world, you're stuck on whatever your mobile operator is willing to provide. So in the end, I think the problem isn't the SIM. The SIM is a brilliant piece of technology. One of the few things in the mobile environment that's kind of open and that could be used for very pro-competitive purposes. But all the other problems that you have with provisioning, with how you contract various networks, the difficulties of working and interworking with all those different mobile networks, that shows how non-competitive and non-competition supporting the whole mobile industry is. And that's one of the reasons people often mistake the SIM as the cause for the problem, whereas it's generally the operator or the group of operators that is that are the problem.
Right. So you're saying it's more of it's the face of the problem, but it doesn't actually, it's not by no means the cause.
No, and it actually, it could have well been the solution. Because if you think of all the Wi-Fi that we have in and around our home, and how hard many IoT devices are to configure for many people, in principle, the SIM can help you with authentication to certain networks, so that it actually could work over a whole bunch of Wi-Fi networks.
Right. I mean, there are people with moves afoot to make that stuff a lot easier on Wi-Fi. I mean, and I wouldn't say that, I wouldn't feel that SIMs were the only way to go. I think that the thing that the other side of this that's kind of interesting is if you look at how hard you're starting to see movement because of Sigfox and LoRa, right? Particularly down at the low bandwidth end. You know, I've heard it countenanced that perhaps narrowband IoT might have a mode that doesn't require a SIM. You know, and because if you're going to compete with Sigfox, you kind of have to be in the same zone, and you know, if you don't get to that, then you're in some sorts of trouble. You know, that because that market will go away.
Yeah, on the other hand, if you run a Sigfox or a LoRa device, it either has a little bit of authentication on it already, which is chip-based. You have the trouble of how do you manage roaming? And more or less with Sigfox and with LoRa, you're both locked into one network provided by one network provider. And with limited roaming across the globe, whereas if you have to run stuff large scale, LTE and narrowband IoT give you a much larger base to work with on a much larger scale, with generally 3 operators per country.
Right.
Now you need a solution to hop between those 3 operators, but at least you have 8 hands of competition if the industry is willing to get it right, which at least the EU Commission currently sees as an option. And it's asking countries to make it possible to get private virtual network operators in. And if you want private virtual network operators in, you need a way to authenticate them and to know where to send the bill. And
right.
Yeah.
And that needs to be a common way for everybody, I guess. So I mean, I think that the area that interests me most, or rather where I think that is the biggest challenge is I mean, you're talking a lot about devices that physically roam, and again, trains and cars are really good examples of that. But if you're thinking about the kinds of places like warehouses and farms where the things that you're monitoring may move around, but within land that you probably own. And in that case, I think then
it becomes all different.
Right.
We did it at the OECD. We wrote quite a bit about this, and we made a diagram, just 4 quadrants, where you have stuff that's local, and it doesn't move around a lot, and you have stuff that is sold globally and doesn't move a lot, or you have stuff that's sold globally and moves globally. And you have various networking technologies for that. If it's local in your building, of course you're not going to use something that costs you a lot for a third party. You're just going to pop down your own network. It's much easier to use either Wi-Fi or some other protocol. You could even use DECT guardband for certain things, which some people do. There's a lot of different options that you have because it's your building, it's your devices. Nobody will just log on to it. You can do the security yourself. But there is this part of the market that needs mobility, that needs roaming. And well, the telecom industry hasn't done a lot right, but kind of work. And there's a reason why they're also in your bank card. And it's basically the same technology. It's really hard to crack.
Right.
It has the right level of encryption on it. It has the right level of authentication. It's kind of the stuff that you can trust to throw a couple of million at. And well, you guys all work in the VoIP business or have worked in the VoIP business. You know what fraud can do to your business case.
Yes. Yeah,
and you know how creative
I totally see the strong authentication angle of it. I just like it's being in hoc to being in the control of the GSMA and through GPP that bothers me. And you know,
and that's why you shouldn't look badly on the SIM, but on all the processes that the operators have created, and where we need regulators to kind of smoothen it out. It's not the fundamentals, because you want strong authentication and SIM cards can give it to you. But you want small companies and large companies to be able to manage their own SIMs, to be able to contract 1, 2, 3, or 4 mobile operators per country based on whatever their business case is. Because if you run M2M, you don't want to be hooked up to one network because you'll be running it for 30 years.
Right.
So you want competition over those 30 years, but also you want coverage. There's no mobile network that guarantees coverage everywhere you operate.
Mm-hmm.
But there is a pretty good chance that if you contract 3 or 4, that you cover most of your customers most of the time.
So it's funny, you're almost kind of you're putting it back into the almost like the 112 situation, where the fact that you can dial 112 against a network operator, even though you don't have a contract with them, means that your coverage map is hugely improved over being dependent on a single operator.
Yeah. And if you run large-scale IoT, that's some of the stuff that you're really looking into. There's a reason why many of the M2M providers that the mobile operators have don't use a country-specific IMSI, or they use an IMSI of, for example, Malta or Luxembourg, which is roaming with everybody everywhere.
Right.
Because they can't even rely on their own network. A major one like Vodafone is set to use this trick. Well, if you're Vodafone and you need this trick to get stuff working for your customers on, because in the end, you may be able to cover 90% of the country very reliably. But of course, your customer will just put all their devices in the last 10% that you haven't covered.
Right.
Because that is a law of telecom business. No matter how well your network is connected, your customer will always be slightly out of reach and then complain about it.
Yeah. So I figure it might be a good idea to open up and see if anybody else has got any questions, and see who's got anything to go for. So guys, speak.
I wanted to underline, Jay Carpenter asked a good question, but I wanted to mention before that I bought for the first time a dual SIM phone. And this kind of underlines the whole discussion in a way because, okay, so it's dual SIM, but it's not triple SIM or quadruple. So, this is an interesting and very finite limit. Jay asked, and he's with us, but I can just ask the question about the viable alternatives to SIM. Obviously, eSIM is one. Where is that thing going? What do you do besides the little card that you have?
Well, for authentication, there's not that much out there. Of course, you can load your own credentials on it, username, password. But how secure is that? And how secure does that remain over time when it can basically just be dug out of memory somewhere? Whereas SIM cards work with the whole challenge and response thing. And so far it has proven quite difficult to clone SIMs in any reliable way without any insider knowledge. And that makes it really hard for fraudsters to make use of it. So other than SIMs, difficult. eSIM is, of course, something that's currently being promoted by the GSMA. Quite interestingly, it's a GSMA standard. It's not a 3GPP standard, which is kind of weird because we have a trade association, a lobbying mechanism, basically promoting a standard, whereas the standards organization doesn't seem to be able to finish the standard. And that kind of gives you a feeling of how various operators around the world view this problem. And I once gave this presentation at the OECD for a Chinese delegation, and one of the three Chinese majors was in the room there. And that gentleman very me that would never happen as long as they were in business. At which point the Chinese regulator, who was there as well, asked how that then would work for Chinese companies wanting to sell on a global scale if they were not willing to cooperate and provide a competitive alternative for Chinese companies to operate on a global scale. At which point there was a bit of an interesting number of glances going back and forwards. Like, are you sure you want that to be your position? Because bigger issues in our country than just whether you like it or not.
Yeah, I think that's really, really nice. I mean, if you look at, I think the only other thing that's kind of starting to emerge is I don't know if you've looked at ARM putting secure elements onto ARM chips. That's starting to look a little bit like putting aspects of SIM functionality right on the die. And that's interesting. I mean, I haven't had a chance to play with it actively. I've read the doc, but not really played with it actively yet. But I think that might actually be a kind of halfway house.
But in the end, that's basically the same, because the SIM is nothing more than an IC. And whether you put that logic on a separate chip or make it part of the SoC, who cares? It is much more the fundamental knowledge behind it that it's secure. And so the question is, who authenticates, who gives the numbers, and who authenticates that really a paying customer, and that the bill is being picked up, so that when a Cuban operator or a Montenegrin operator or a Croatian operator sends you a bill, that you actually go like, yes, I like that. I'll pay it. And we all know the trouble there is with dialing numbers in Cuba when it comes to VoIP networks. Yes, there's a bill, it needs to be paid, but we're not happy about it, and we don't really trust it. And if you want to do this on a global scale, you need secure authentication. And whether that is stuck in a SoC or in a separate chip, nobody really cares. It's much more the whole process around it that makes sure that everybody believes that this is the correct answer. And well, that's the one thing that GSM has done really well.
Could we just back up for a second and just look at, for people like me, I have an idea what a SIM is, but can we talk about, you arrive someplace where there are towers, operator X is there. What is the dialogue with the SIM? There's a number. Each phone has its number, and my phone has two numbers because it has two SIM slots. That's the, I don't know how to pronounce it, but I know the number. Can you give us a quick view of what happens when I turn my phone on in America and I've got a T-Mobile SIM in it, for example?
So basically what a phone first starts doing is sending its IMSI number. And the IMSI number is International Mobile Subscriber Identity. It is digits, and the first three digits identify the country, and the second two or three identify the mobile operator. And this is handed out by the mobile operator of the, or by the regulator of the country. And based on those 5 or 6 digits, all the traffic then gets routed. So T-Mobile then checks in the US, who does this belong to? Well, if it's themselves, then it's easy. But if it doesn't belong to them, they look at the second list and go like, with which set of mobile country codes, mobile network codes, we have a roaming agreement. Well, if it's 1, 2, 3, 4, 5, and we have an agreement, then yes, I will send the data, the authentication data, onto their HLR. They will authenticate, and if it comes back that yes, we really like that customer to be present on your network, and we will gladly pay the bill, then presto, you get access to the network. If they report back, no, that customer doesn't have roaming credentials, then it drops off. If they don't recognize the first 5 digits of the IMSI, then your phone will try another network and try another network and try another network. And then after a while, it will tell you that it doesn't find an available network. But basically, it's all the first 5 digits, and somebody, meaning a government, has authenticated you to have those first 5 digits, and then to issue your own numbers. And after that, contract is signed between operators where those numbers are exchanged and signaling point codes and the whole shebang, and then life becomes easy. About the email, which is part of your phone. It's also not about your phone number as such, though of course that does get exchanged as well. But it's really the IMSI that is the part of the authentication and the thing that operators build each other on.
Okay, thanks for that.
So we've got Mr. Bodie finally. He's finally arrived in the Batcave or wherever it is.
Bodie Countess +1.
Yes. So James, I don't know how much of that you managed to listen to on your path through.
Little tiny fragments, and I wanted desperately to listen, and it was very frustrating. So I've done the fastest transit from Salisbury out to the country anybody's ever experienced. I think.
Cool. No, I mean, we were literally just talking about the process of how SIMs relate to the network, and to what extent. I mean, the point that Rudolf had made that kind of came as, I knew it, but I hadn't like really added it up, was that the SIMs don't represent necessarily like, they're not necessarily the problem. It's more to do with the carrier attitudes, and that the SIMs could actually be a solution to inducing more competition in this space.
Indeed. In fact, just if we're punching terminology, it's worth pointing out that the SIM or USIM actually is a lump of code that sits upon a receptacle, normally known as a UICC-ID. So the little thing that you put in your phone is not actually it is the SIM, but the SIM is the code or the content of the receptacle that you put in. So that's a UICC-ID, a universal, whatever it stands for.
Yeah, and in the end, it's basically guaranteed by companies like Gemalto and Overture that it's secure, and they use basically the same technology that they use for your bank card and your credit card. It's more or less the same chip. So the point behind it is this isn't easily hackable. You can trust a lot of money on it, and that is what makes it so cool. That's basically what you can use to build global commerce on. Unfortunately, if you want to buy roaming at the moment, it is desperately hard. You can ask the guys from, well, Truephone or similar companies how hard it is for them to get roaming deals around the world. But that has nothing to do with the technology. If this was the IP world, it would have likely have been a lot easier, and we would have seen a lot more competition. But these companies have created very interesting processes whereby making it very, very hard for others to get access to their networks. And it doesn't have to be, because roaming in itself, look, the network doesn't care what IMSI you use. The network itself is IMSI agnostic. It doesn't even recognize the own IMSI as own IMSI, because it's just a number and a billing relationship.
Indeed. The other thing
and a switch where stuff needs to go.
Yeah, the other thing we mustn't forget is it's more than just the IMSI. You've also got sets of cryptographic key variables that go with the IMSI. And whilst it's possible to push new IMSIs dynamically across the air into a SIM, the issue comes with which set of cryptographic key variables do you use to authenticate with, and where's the other half?
Yeah, and in the end, that's where companies like Gemalto make their money, in guaranteeing that nobody knows the exact cryptographic keys that you use, and that's all secure and therefore.
I think that probably Gemalto is a very bad example to use.
Yeah, okay, well, you use Overthrow or any of the other ones, but yeah. Let me just put it this way: Gemalto was one of the few companies willing to talk about this, even on the record. The other ones weren't willing to discuss this ever at all when I was writing about this. So, yeah.
Right. So the bit I missed was what the solutions are. What the conclusions?
Regulation. The regulator has to force. I mean, I'm putting words into Rudolf's mouth, but basically, the regulator has to push the more support for this kind of for the ability to run your own mobile networks or mobile virtual networks even, and issue your own SIMs and numbers to more capability, more organizations. So things like, I mean, the example that we started out with was the Dutch Railway and the blue light services are people who should be running their own networks.
Oh, yeah, that's a bit that I did hear. Rudolf, did I hear you right when you said that your recommendation was that the railways or the blue light services should have their own dedicated spectrum? Did I hear that right?
Yeah, yes and no. In the Netherlands, we had a consultation, or we actually have an active consultation on the future of mobile and what to do with the 700 megahertz. And there is 2x5 and 2x3 megahertz of spectrum available there, which is kind of like a guard band spectrum that isn't easily commercially used. And that doesn't have much commercial value because there's 3x10 available as well. Now, the government was wondering whether it should give 2x10 to the blue light sector, like, for example, the Swedes are contemplating at the moment, or if, for example, that 2x8 that's available could be used for the blue light sector.
Mm.
And the blue light sector, of course, already has their own CDMA network. And what we advised them to do was come up with a hybrid model where 2x8 can be used for dedicated blue light sector stuff when, for example, you have a very big event and the airwaves are full. And they still have a little bit of their own spectrum where they won't be blocked by any of the other people that are using their phone at the moment. but at the same time that they buy commercially on the market from 1, 2, 3, or 4 mobile operators access to their commercial networks, not just on the 700 megahertz, but also on the 800 to 900. And they have the flexibility of moving in and out. And we already have some experience with that in the Netherlands with DECT guardband network, with the Dutch Department of Defense, which is more or less done the same without using their own spectrum dedicated. But at least the Dutch Department of Defense was the first private operator to get their own IMSI ranges in the Netherlands, and actually installed them on Navy ships and in Afghanistan. And when I actually told this to the ITU in Geneva, when we were discussing that the ITU needed to liberalize access to IMSI numbers, one of the ITU people reminded me that it was against ITU rules for a country to run its mobile network in a foreign country. At which point I told them, well, I don't think that Department of Defense cares a lot.
There are a lot of mobile networks out there. And just from my personal experience, going back, 20 years almost, I was putting 2G base stations on the back of C-130 Hercules in my previous life. So, so we deployed 2G GSM, 18 years ago, militarily?
Yeah. Kind of same what the Dutch government did, and they also use it for emergencies. So they actually have a whole emergency unit that can set up when they want to. And it's kind of what we fought for the blue light sector as well. And then they can just piggyback. But not like the UK has done, where you just dump everything towards EE. To actually create a competitive model.
Yeah, I'm not hugely comfortable with that for a number of reasons. Anyway, did you consider, from a spectrum management point of view, licensed shared access (LSA), or where you can dynamically issue leases for spectrum as it's needed? And then release the spectrum when it's not needed? Was that a consideration for you?
Not in this report that much, because it's not a consideration for the type of spectrum that's being used. So there is, in the Netherlands, there's actually quite advanced with private use and unlicensed use of, for example, of guard bands. So the DECT guardband, where in the UK you needed a license, in the Netherlands you didn't need a license to run your own LTE network in the DECT guardband.
That's in the Netherlands. Now, is it permitted to run narrow LTE in DECT guardband?
Yeah, has been for the last 7 years.
Am I right in thinking that hospitals and people like that do run their own networks in that way in the Netherlands?
Yep, quite a lot. If you look at companies like Radio Access, they have a very nice business out of it.
Yeah,
that's to make it more easily stick. Radio Access.
In UK, it's only become possible in the last year to run LTE. The problem is the DECT guardband is just a little bit on the narrow side to do anything meaningful with LTE.
So the Dutch government actually widened it a little bit.
Oh, good old Dutch government. I wish we had the Dutch regulator working right the way across Europe. It'd make life a lot easier, wouldn't it?
Well, sometimes, but you know, I've worked for a telco as well. There was a lot to complain about as well. Ofcom does some stuff well. Others, in this case, the Dutch government did quite all right.
Yeah.
You know,
I was amused to see that the Dutch Railway was involved in those early discussions, and it reminded me of back in the day. They ran the backbone for the Dutch public internet that was run on the Spoorweg's spare fiber that was running along the tracks. That was before they were even privatized, and then. Because I think if I remember rightly, the telecom people really weren't interested. It was too, it was too difficult for them. But the Spoorweg were interested and went for it.
Yeah, well, actually, they were one of the founders of one of the mobile networks in the country, which was partly, so the BT network, BT Telfort, was a joint venture with Dutch Rail, and it ran most on the fiber that Dutch Rail had between the various cities. And that's how it did all its backhaul, bypassed KPN in that respect.
Yeah.
So, yeah.
Railway communications are a bit of a hot potato at the moment because, as you're probably aware, the replacement for GSM-R, the railway GSM, is bubbling at this moment in time. And and I attended a working group where all the European rail operators were going, oh, we need at least 5 to 10 megahertz of dedicated spectrum, and I was part of a group who were going, no, you don't. What you need is license shared access with priority access in the areas close to the railway lines. The big problem with assigning big lumps of dedicated spectrum is that it kind of clogs up the spectrum right the way across the country. And for the railways, I guess only about 5% of the landmass needs to be covered. And so a much more efficient mechanism is to give the railways priority access to license shared access spectrum in the areas where they need it, but everywhere else, everybody else can bid for that spectrum and use it. Much more efficient.
Or maybe just put them on commercial networks and make them private virtual network operators. And
I very much like the idea of having a narrow, dedicated signaling channel, which you can use for authentication signaling purposes, where you can then, using the LTE prioritization mechanisms, you can preempt service on commercial networks.
Might well be possible as well.
But in order to do that, you need a really good dedicated signaling channel to allow you to do that.
I think it's still very meaningful to see that a lot of the M2M stuff that rail companies are doing isn't actually on GSM-R.
No, indeed. So, I think the favorite at the moment is this, what is it, the 20 gigahertz trackside to train mechanism. I can't remember what frequency band.
Oh, in the Netherlands, it's just GSM.
Okay, well, what we were talking about was the trackside to train communications, which not only by the train signaling, but also by the people on the train. So conceptually, what you do is you put small cells in the train, operating as multi-operator neutral host mode, and then run a fat backhaul. Oh dear, Rudolph. Oh yeah, you're still there. It's just Tim making noises. And then you run a fat pipe.
I didn't hear what it was.
Thank you. A fat pipe off the front and back of the train. I'm not winning here, am I?
Alexa.
No, don't you dare. Which then allows everybody to use their mobile devices whilst on the train. So if you can get something like a gigabit feed onto the train, that can probably provide enough backhaul to run multiple multi-operator neutral host small cells in each carriage.
Yeah, we'll see. Yeah. There's multiple options there, so we will see where that goes in the market.
Yeah, but I think this question of having big chunks of dedicated spectrum is just an old-fashioned concept, and we really ought to try and avoid that.
Normally, I agree. With the blue light sector, it might be a little bit different because they have very particular needs, which I can actually sympathize with, given that we have had a situation in the Netherlands where networks were overloaded and the police couldn't report back to their head offices anymore and that kind of stuff. And
yeah, but there are mechanisms in both 2G, 3G and 4G to allow prioritized access to emergency services. So as long as that's managed properly, that should not be an issue at all.
I think the part of the back data for that is that was it Vodafone who lost coverage basically lost half the network in the Netherlands for about a week. Where are we? 10 years ago, maybe now?
Not even. This was 2012. 5 years ago.
I was thinking of it. They had a fire in a major switching point, and basically they lost half their network for a long time. And and if you were relying on that, you'd be stuffed basically.
And so that's one of those things that was very much prominent in the thinking of the emergency services in the Netherlands, that you can't have that. You can't build a network like that. And in some ways they have now with CDMA. Not CDMA, I mean C2000 Tetra, which they run themselves. And it's very much, of course, dependent upon themselves. But one of the things that we put forward was that, look, you can now buy access on 4 different commercial networks and actually get much of what you want in a way that if somebody fails, because you have your own SIM cards, because that's where it all starts, you have your own devices, you can actually buy access. And this is and that's currently unused, that because of all the various rules and regulations would be unused. The French are now moving, the French were basically the first ones to come up with this idea. The Germans are moving this way as well, the Dutch are thinking about it as well. It's a band that might be used in the Middle East for commercial purposes, so probably we will end up with silicon that can use it. And that would be a very interesting solution to a problem.
The challenge with it, of course, is that you still have to deploy another complete countrywide radio network, which is
no. You just use the radio network of the operator that you're on. That makes it actually quite nice. So you don't have to build out in the Netherlands between 2 and 3,000.
On this dedicated spectrum?
Yeah, because the antennas can use it, because it's in the same band as all the other 700 megahertz LTE stuff.
Yeah, but what about the not spots? I suppose not spots are less of a problem in places like the Netherlands, because we tend not to have valleys and.
No, we actually do have those problems, and sometimes even in the city center of Amsterdam. So we actually have 50% more antennas for our Tetra network for the emergency services that were initially envisioned.
Yeah. In fact, urban coverage is a big problem. The mobile network operators tend to deny that it is a problem. I'll give you an example. Canary Wharf in the city of London, or just outside.
Well, nobody lives there.
Nobody lives there, that's true. But all of the mobile network operators claim 100% coverage on all modes. And you look on the map and it's 100% green. There are no not spots in Canary Wharf. However, you go into a building, if I told you that something around 50% of Canary Wharf estates, so in the buildings, has little or no mobile coverage.
But there are a couple of factors there, James, one of which is simply height, that most of these network coverage diagrams are based on ground level.
Ground level, absolutely right. And the other
non-metallized windows.
Yeah, the other factor is the loss that you incur going into window. I mean, the standard loss that is used normally to estimate loss going into a building is of the order of 15 dB, but going into a bank type building in Canary Wharf, the average is closer to 40 dB isolation as you go in. And the reason for that is that banks really don't want to have people sitting outside listening to their Wi-Fi or other emissions. So they tend to make their buildings into Faraday cages.
Yeah, and even if you don't have that, in 2004, 2005, the Ministry of Economic Affairs in the Netherlands moved their Department of Telecommunications into a different building in the middle of The Hague. And we had full signal, but we had continuous dropouts. Why? Because we had full signal, and the device would try to tune on to whatever was the strongest signal. So the moment you turned your head, you moved to a different antenna. But there is this mechanism in most mobile networks that tells the network to drop you after you have hopped an X amount of antennas in a certain amount of time. So either you were advised to sit very, very quietly and very, very still. Of course, nobody does using a mobile phone. In the end, they had to provide indoor coverage in the building, not because it lacked signal, but because it had too much signal, and it needed slightly more signal, so that it wouldn't latch on to anything else anymore.
Yeah, and this really is another, what we've got to get to is regulation whereby people who own buildings can actually deploy their own mobile infrastructure inside the building, I think.
I remember discussing this with I think it was the fire chief in San Francisco, and he was saying that this joining those two topics up about coverage and blue light, he was saying it'd be really interesting to be able to run a femtocell on the back of his fire truck. So if he can turn up at an incident and turn on his own coverage, which, you know, and I don't think they ever got around to doing it, but it was an interesting conversation.
Well, that probably wouldn't help you in Canary Wharf. As soon as you go into the building, you lose coverage again.
Yeah, no, but this idea of being able to run coverage where you needed it, but still be part of the big network is an interesting, and basically only the regulator is going to be able to force that behavior.
Yeah, and the big MNOs will not like it at all.
How would you backhaul that off a truck?
Exactly. Well,
yeah. Don't know. We didn't get that far in the discussion. Although, I mean, if you're only on 2G, if you're doing 2G voice and SMS, you can backhaul it, you know, pretty trivially.
Yeah, but people don't want 2G, Tim. That's the problem. They all want data.
I know they do.
And they want data with some form of quality of service.
But here's the thing: in the emergency, actually, you'll settle for voice and SMS rather than nothing. If those are your choices.
Yeah, but no, you want all the data, and that's why we advise them to use their own 8 megahertz, and then actually you could use that in combination with a lot of different stuff. You can actually hook up your own femtocell or picocell, run it in your own 8 megahertz, use the other stuff to backhaul it. There's a lot of flexibility that you get once you have your own spectrum, and this is kind of important. So there's a good chance that that government will move this way. At least it's what it's currently considering.
Yeah.
And it's not like you're locking up the whole market. It's just a little bit of flexibility. That's basically also what.
This is where I come back to this concept of spectrum on demand, where you have a mechanism which issues leases, short-term leases on chunks of spectrum as you need it.
Yeah. Might be possible.
We'd really like spectrum leasing for the kind of events that we go to, for the conferences and stuff. I mean, like Camellia World, which is going to be in Berlin in, where are we, 3 weeks time or something? Mm-hmm. And also for ClueCon in Chicago. It would be great to be able to run our own spectrum, and you know, and also presumably at things like festivals and whatever. But that doesn't, you know, it's simply impossible.
Come to the Netherlands and do the guard band.
Yeah, that's interesting. So I've forgotten what the hacker camp is called, the Dutch hacker camp that happens every few years. I wonder if they've run
it never has the same name. In 2001, it was called Hacking at Large 2001, HAL 2001.
Right.
And it was at 20 universities. So basically, it was my internet exchange then. And but yeah, it has been called Hacking in Progress and several other things. But it's every 4 years, and the organizers are good friends. It will likely be very soon again. So,
but there's a
you can
perfect
play with
place to run your own network.
Yep, and they do.
Okay, cool. I mean, I know the CCC have in the past in Hamburg, but I think they struggled to get Spectrum this year. I think they did in the end, but I can't remember the end of the story there. But
yeah, German bureaucracy is interesting. The way they operate is that if it's not in the rule book, you can't do it. Whereas in UK, we tend to work the other way around, which is if it's not in the rule book, you can get away with doing it.
well, I mean, it used to be that that spectrum was allocated. It was allocated to one of the carriers, and they were happy for it was test spectrum, and they were happy for the CCC to use it. But I think a couple of the exploits a couple of years earlier had embarrassed them, and so it was difficult for the technical people to say, yeah, okay, fine, because it suddenly became a publicity thing as well. So it kind of escalated.
It is possible to get Spectrum. I've had Spectrum on a number of occasions, and just through the regulator, you can apply for an experimental license, and you can do, well, virtually anything you want, as long as you don't charge money for the services.
Yeah, I mean, we had Spectrum in the Moscone Center in downtown San Francisco for a week during Google I/O. So it's doable, provided, as you say, you're not going to make money out of it. And I think you have to show what the experiment is. Like, if you're not like testing something, then it's kind of hard to justify.
Yeah. Well, going back to SIM cards a little bit, because that's what all of this started in the end. Germany was interesting because we showed in an OECD report that it was one of the 2 OECD countries that didn't allow MVNOs to have their own SIM cards. So a German MVNO couldn't get the IMSI numbers, couldn't get its own mobile country code or mobile network code. And only recently has that been changed in German law. But if you then look at what kind of competitive effect it has for MVNOs, that they would be completely hooked up to the mobile network that they were located on. That was quite an interesting thing to see, and very anti-competitive in many ways. So.
Cool. Well, I think since we've done our hour, it would be good to kind of have a last question or two here and there. I don't know if Kathleen's got a question or Michael or anybody else, and then we can maybe wrap up. Randy's abandoned ship, or oh no, he's showing the Come in Your World timer.
Somebody mentioned to Come in Your World, and
yeah, it was me. I said 3 weeks. I'm not far off.
20 days, 13 hours, 48 minutes, and 45, 4, 3, 2, 1 seconds. Okay.
So any questions anywhere? I'm looking at Kathleen.
I'm looking at Andy. Andy's been here taking notes. I watched him. So
Andy, I bet you've got a question or two, haven't you?
Not particularly. I've been actually more interested about the discussion, argument, whatever you want to call it, about the difference between using eSIM and UICCs. But nobody mentions soft SIMs at all. So are those, do you think, pretty much dead? I mean, I wouldn't want to trust a bit of software running on another process on a system on a chip on a board.
Well, the question is how you protect the cryptographic key variables. So you've got to be able to secure them in such a way that unscrupulous people can't extract them and duplicate them or do nasty things with them.
Which basically says soft SIMs are a non-starter.
Well, yeah, I think there's a border there in terms of just what I was saying earlier about the ARM making secure elements. I think that if you could get the secure element with the right semantics that would support a soft SIM, then you could do that. Now, whether you still think that's a soft SIM or whether you call it an eSIM is like semantics.
Then it isn't a soft SIM anymore. Then it's basically just an eSIM in a different piece of silicon. But it basically needs something hard-coded into the silicon to do all the authentication. So
there are other mechanisms that you could use actually to for authentication purposes, or use factors in an authentication system. I don't know whether you've seen the thing where a bit of computer hardware is fingerprinted, and you actually use that hardware fingerprint, which is actually in the silicon, as part of the authentication process. So it's not the entire authentication process, but it's a factor. And unless you have access to the actual physical silicon, it's very difficult to ascertain what those variables are in the authentication stream.
Yeah. In the end, that basically ends up being the same for all means and purposes. So, you need some kind of guarantee that it works and somebody to sign off on it and stake their reputation on it. So, what I heard from major car manufacturers is that they want their own. They like the idea of having their own SIM cards because of the competition possibilities that it gives them. But I also want an eSIM because if you own multiple brands, say you want to sell, say you're BMW and you want to sell Mini, or your Volkswagen and you want to sell Seat, for whatever, well, General Motors and you want to sell Opel. General Motors has just created an interesting problem for itself because it's actively promoting OnStar-based cars in Europe at the moment, just when it sold Opel Vauxhall to Peugeot. Now, what do they do with those devices that are on there for the next 15 years? How free are they to move? So,
well, I think the answer to that is using the old technology. There has to be some kind of physical switch of something like a SIM.
No, but they can't. In the US, they actually had this problem when they moved from Verizon to AT&T, and all the old stuff remained on AT&T, and all the new stuff also remained on Verizon, I think, and all the new stuff was on AT&T. Welcome to the modern world of being a major car manufacturer and owning millions of devices and a mobile operator than the average teenager does.
Welcome to the world of IoT. That's my feeling.
Yeah. Well,
did you see, by the way, that the cookers got hacked? The Arga, the famous English cooker, they got hacked.
How can an Arga be hacked?
Apparently, apparently, James, they do a connected model of the Arga, and they had very weak authentication about how it comes with a SIM card. Bless it. And
You're kidding.
I am not. I will put.
Well, most Argas live out in the country.
James, I've found it myself, but it's well sourced. This anyway. We'll do that in the section when we cut the recording. But I did want to get in a question about ClueCon, and maybe Kathleen could tell us what we can expect from ClueCon, which is coming up in, where are we? A couple of months.
August.
Yeah, August 7th through the 11th. We're pretty excited about it. We've got some really cool things planned, a lot of really great night activities. So, and this year, actually, we're kind of excited because we have a boat party. That'll be taking place on Thursday evening. So for those of you that are stick around a little bit. And then I guess the biggest thing for ClueCon is if you want to speak, get your speaking proposals in. We're closing that on May 1st so that we can make the schedule and people can see who to expect. So yeah. So
are you doing an IoT theme thing this year or not? Because I know you did a couple of years ago.
We are actually. Our the first day, Monday, our hackathon, we're going to have some really cool stuff for you guys to play with. Last year, we had a little competition to see what people could build. And I think the winner ended up building a Wi-Fi coffee ordering device that they worked with FlowRoute, who is providing coffee that you could, text in and tell them where you were and get your coffee delivered to you. And these guys took a little, I think they took a Raspberry Pi and ended up making a Wi-Fi enabled ordering device with little LEDs, so you could tell when it went through or if it didn't work or whatever. So it's really cool. We're going to do that again this year. So, and actually we might expand upon it a little bit as well. So be sure
Yeah,
to join.
do jelly bears as well as coffee.
Yeah, those are good. Actually, we'll have to figure out where
Bears,
to
yeah.
get those.
Or whatever the Chicago equivalent is.
I'm not sure little jelly pizzas would be a good idea.
Hmm.
I
And
can
don't-
recommend the boat trip, by the way. I did a boat trip around Chicago a couple of years ago, and the architecture from the water's viewpoint is just spectacular. Really, really good to see. So I can encourage people to join in on that. It was great.
Yeah, this will be really cool because I guess what you do is you go up and they take you through the architecture a little bit, and then they take you back out into the lake and you get to watch sort of the sunset behind all the buildings as you sort of drive around the lake a little bit, and it's gorgeous. And there is a bar on board for those of you that would like to drink a little bit as well. So it's going to be really neat.
And can we just confirm we are doing dangerous demos this year?
We are. We do. We have a lot of fun stuff in the works. So yeah, join us for that. Like if you make something cool during the hackathon day, feel free to incorporate that into your dangerous demo.
Okay, with that, we're going to go to the mature audiences only segment. Thank you, Rudolph. It was great having you, and we hope to have you back again one of these days. I've been watching you forever on Twitter.
Cool. Thanks, guys. It was really fun.
Yeah.
It was great to have you. Kathleen, as always, thank you. And thanks to everybody, and even the regulars. What the heck? Thank you, guys. It's nice to have you, too. I just want to remind people, we will be at Kamaillo World, the May 8th in Berlin. Berlin is a fantastic city. Try to make your way there if you can. Also wanted to do a quick shout out on the next week. Dan Jenkins, friend of the show, as they say, will be here. And the week after that, Algo VPN. Michael will be running that thing. And I just signed our guest, Vlad Markov, for Cisco Spark the next week, May 5th. So we're hopping again, folks. This is a good season for VUC. Thank you, everybody. IP Communications and VoIP community. We are out of here, but we're still talking. You just won't know it.